Hello everyone, I am Mohammad Ahmad Qureshi, working as an assistant professor in Civil Engineering Department at RNG Patel Institute of Technology, Bardoli. So, we are studying mechanics of solid subject and in which our topic is co-planar concurrent forces. And in that portion, we will study today Polygon law of forces. Till now, we had seen parallelogram law of forces and its example, triangle law of forces and its example, resolution of a force and its example, and principle of resolution as well as resolution of more than two concurrent forces. Now today we will go for polygon law of forces. So the statement of polygon law of forces is that if a number of forces, here there are number of forces. The first force is P1, second force is P2, third one is P3, and the fourth force is P4. So here number of forces are acting at a point be represented in magnitude and direction by the sides of a polygon. Means these forces are represented in magnitude and direction by the sides of a polygon. This is your first side, second side, third side, fourth side. By this way, your forces are represented in magnitude and direction taken in order, one by one after the other. Then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon taken in opposite order. Remember this word, taken in opposite order. So we will now go for polygon law of forces. This is your space diagram. First of all, we have to plot the space diagram to some scale and we have to give Bose notation. I will briefly explain you Bose notation afterwards. Then we have to select a suitable point. Suppose this is a space diagram that we had made it. Now we have to select a suitable point. So I am selecting a suitable point, that is A. So I had select one point to the right side of the space diagram and the name of the point is given as A. Now from A we have to draw a line AB. From A we have to draw a line AB parallel to force P1. So here I am writing A, B and our first force, that is P1, and the direction of the P1 force is this. Now from A we had drawn a line AB parallel to force P1 and in magnitude to some suitable scale. We had assumed some suitable scale. Now from point B we have to draw a line BC which will be parallel to our second force, that is P2. So here from B I had plot a line BC which is parallel to force P2. So this will be your second force. Now similarly I have to plot a line CD from C point and which will be your third force, that is P3. So from C, draw a line CD parallel to P3 and in same magnitude. So here is your third force, that is P3. Now again for fourth force, we have to draw a line DE from D parallel to P4 force and in same magnitude. So this will be your fourth force. Now all the four forces have been plotted in vector diagram. Now this is your closing line. You have to draw a closing line. So your closing line will be AE. Your closing line will be AE. This AE line will give you the resultant, that is the magnitude of resultant force. And here your theta will be the angle of resultant. So this is your Polygon law of forces. What does it states? It states that if a number of forces acting at a point be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon taken in opposite order. Now we will move further. That is system of forces. Now I will explain you in detail about the Bose notation as well as vector diagram, and you had already studied the space diagram. So here this is the system of forces: 80 kilonewton, 60 kilonewton and 70 kilonewton. 60 kilonewton making an angle theta 1 with the horizontal x-axis, 70 kilonewton making an angle theta 2 with the horizontal x-axis, and 80 kilonewton making an angle theta 3 with the vertical axis. Now second is our space diagram that we had discussed earlier. What is space diagram? If the forces acting in the system, so these are your forces: 80 kilonewton, 60 kilonewton and 70 kilonewton. If these forces are acting in a system are represented by direction in the form of diagram, what does it states? That if the forces acting in a system and represented by direction in the form of diagram using Bose notation, then the diagram is known as space diagram. This is your system of forces and this is your space diagram. All the things are same except A, B and C. So this A, B and C are nothing but the Bose notation. So what is Bose notation? While drawing the space diagram, each force is denoted by an English character. While drawing space diagram, each force is denoted by an English character on either side of it. Then this system is known as Bose notation. So here 16 kilonewton force is denoted by two characters, A on one side and B on other side. Hence we may say that the force AB equals to 60 kilonewton. Similarly, your 70 kilonewton force is denoted by two characters, B on one side and C on other side. Hence, we may say that force BC equals to 70 kilonewton. Similarly, your 80 kilonewton force is denoted by two characters, that is C on one side and A on other side. Hence, we may say that force Ca equals to 80 kilonewton. So this is known as Bose notation. While drawing any space diagram, if each force is denoted by an English character on either side of it, then it is known as Bose notation. And lastly, vector diagram. So to find the resultant force of a coplanar concurrent system, each force of a space diagram, here 60 kilonewton, 70 kilonewton and 80 kilonewton. So these forces of space diagram is represented by magnitude and direction. Then the diagram so obtained is called vector diagram. So look here, your 60 kilonewton force parallel here 60 kilonewton force, and we had given this point as A and B. We had select a point A. From point A we had draw a line AB which is parallel to this force. So here this will be your 60 kilonewton. Now from point B we had draw a line BC parallel to 70 kilonewton force. So this will be your 70 kilonewton. And from point C, we had draw a line CA parallel to 80 kilonewton force. So this will be your 80 kilonewton force. So each force of a space diagram is represented by magnitude and direction to find the resultant force of any system. Then such diagram is called vector diagram. Now we will go for examples on Polygon law of forces. So what is given? Two forces 30 Newton and 40 Newton, both tensile, both force are tensile force, means they are going away from their point of intersection and are acting at an angle 90 degree between them. The angle between 30 Newton and 40 Newton is 90 degree. Find graphically the magnitude and direction of the resultant, means we have to calculate the resultant, that is r, and direction, that is alpha or theta. Now this is your space diagram and the space diagram is already given in your example. So here let us assume that P equals to 30 Newton and Q equals to 40 Newton. And both forces are tensile. So both forces are going away from this point and both forces are acting at an angle 90 degree between them. Now we will give the Bose notation to this space diagram. So I will write A before P as well as B after P. What is Bose notation? While drawing space diagram, each force, here force is 30 Newton, is denoted by an English character on either side of it. So I had given an English character A as well as B on the side of P equals to 30 Newton. And here the force is Q equals to 40 Newton. So here B is already available. So on the another side, I will write C as Bose notation. So here force AB equals to 30 Newton and force BC equals to 40 Newton. Now we will go for vector diagram. And as we had studied earlier that we have to first select a suitable point A. Suppose your point is A to the right side of the space diagram. Now, from point A, draw a line AB parallel to force P equals to 30 Newton to some suitable scale. Here, I am taking the scale as 1 centimeter equals to 10 Newton, as we have to solve this example by graphical method. So I am taking the scale as 1 centimeter equals to 10 Newton. So this will be your approximately 3 centimeter. You have to put your scale, and from this point to this point you have to consider 3 centimeter. Now from point B, draw a line BC parallel to Q equals to 40 Newton. So here your BC will be 4 centimeter, as 1 centimeter equals to 10 Newton, therefore 4 centimeter equals to 40 Newton. Now, so what will do we next? We have to draw the closing line, that is C to A, closing line C to A. This will give you the resultant, that is magnitude of capital R. So by this way you have to create your vector diagram using your scale. Now we will write here capital R equals to, we know that capital R equals to AC. So A, value of A, C. So now we have to put our scale at this point till this point, and we have to measure this distance on your scale. So you will get this as 5 centimeter, and we had taken the scale as 1 centimeter equals to 10 Newton. So here 5 into 10 Newton. So you will get resultant as 50 Newton. Your resultant will be 50 Newton. Now, by using your protractor, put your protractor point here and measure this angle alpha. So you will get alpha equals to 50 degree with Q force, that is 40 Newton. By this way, you have to calculate the magnitude as well as direction of the resultant force. First of all, you have to just select a suitable point A to the right side of any space diagram. Then your second point will be, from that point you have to draw a line AB parallel to the given force and in magnitude to some suitable scale. Now, from the second point, you have to draw the another line parallel to the other force and draw the closing line, and your this closing line will be your magnitude of resultant. This way, you may easily calculate the resultant, that is magnitude of the resultant and direction. Now we will go for second example. Here what is given? Two forces, 20 kilonewton and 30 kilonewton. Both are tensile, means both forces are going away from their point of intersection and are acting at an angle 60 degree between them. Find graphically magnitude and direction of the resultant. So first of all, we will draw the space diagram. And we know that, let us assume that P equals to 20 kilonewton and Q equals to 30 kilonewton as given in data, and the angle between them is 60 degree. Now we will give Bose notation. So here I am writing as A and here as B. So your force AB equals to 20 kilonewton, and here on the another side of Q equals to 30 kilonewton, I am writing here C. So force BC equals to 30 kilonewton. So your space diagram is complete. Now you have to draw your vector diagram. So as we had done the process in first sum, we have to apply all the process similarly. So here we are selecting a point A to the right side of the space diagram. Now, from point A, you have to draw a line AB parallel to force P equals to 20 kilonewton. So here I am writing P to some suitable scale. Here I am taking scale as 1 centimeter equals to 5 kilonewton. Okay. Now, from point B, you have to draw a line BC parallel to force Q equals to 30 kilonewton. Now, this will be your closing side. So, this closing side will give you the resultant, that is capital R. So, from this point to this point, you have to measure this distance by your scale. So, your distance will be 4 centimeter and your this distance will be 6 centimeter. So you will get the resultant force here. So capital R equals to AC equals to, you have to measure this distance. So you will get the value of resultant here. Then we have to find the value of alpha. So you have to put your protractor here and measure the angle alpha. So you will easily get the value of alpha over here. Now we will go for third example. Find graphically magnitude and direction of the resultant for the system shown here using graphical method. So first of all, we will give the Bose notation. So here before 20 Newton, I am writing here A, after 20B. So Bose notation is clear. Force AB equals to 20 Newton. Now here after 25, I am writing here C. So force BC equals to 25 Newton. After 30 Newton, I am writing here D. So force CD equals to 30 Newton. And after 40 Newton, I am writing here E. So force DE equals to 40 Newton. So we had created the space diagram. Now what we have to do? Now again same procedure. We have to select a point A to the right side of the space diagram, and from point A draw line AB. Draw line AB which will be parallel to 20 Newton force. So here let us give as 20 Newton. Now from point B draw a line BC parallel to 25 Newton force. So I am just denoting this by 25 Newton. Now from point C draw a line CD parallel to 30 Newton force. So this will be your 30 Newton. Now, from point D, draw a line DE parallel to 40 Newton force. Now, draw the closing line EA and in opposite order. So this will give you your resultant. Here consider scale as 1 centimeter equals to 5 Newton. And with the help of protractor, you have to find the angle theta. So you will get the value of theta according to the protractor. By this way, you have to calculate the value of resultant, that is capital R equals to EA equals to your answer that you will get by measuring this distance by scale into pi Newton, as we had assumed that 1 centimeter equals to 5 Newton. So you will get your resultant over here, and by using your protractor you will get the value of theta to some degree. So if you measure this distance, you will get 5.2. This distance will be 5.2 into 5. So you will get as 26 Newton, and you will achieve the value of theta as 32 degree. By this way, you may solve and obtain the magnitude and direction of the resultant. Now, we will go for the fourth example, that find graphically the magnitude and direction of the resultant. So first of all, we have to create our space diagram, and for space diagram we have to give the Bose notation. So here before 100 kilonewton I am writing here A English character, and here B. So force AB equals to 100 kilonewton, and 150 kilonewton above is B. So I will write here C. So force BC equals to 150 kilonewton, and after 180 kilonewton I will denote by an English character D. So force CD equals to 180 kilonewton, and here after 120 kilonewton E. So your force DE will be equals to 120 kilonewton. Now again, we have to repeat our same procedure. That is, we have to select a suitable point A, and this point will be your right side of the space diagram, and from this point A, draw a line AB parallel to force 100 Newton. Okay. Now, from point B, you have to draw a line BC parallel to 150 kilonewton force. Now, from point C, you have to draw a line CD parallel to 180 kilonewton. Now, from point D, you have to draw a line DE parallel to 120 kilonewton. So, this will be your closing side, and this closing side will give you your resultant. So, here capital R equals to the magnitude of resultant, and which will be in opposite order. So here we are considering scale as 1 centimeter equals to 20 Newton, and this will be your angle theta. So capital R equals to, after plotting all this line up to 1 centimeter equals to 20 Newton scale, you will get the closing side, that is this dotted line, using your scale as 7.4 centimeter. So your capital R will be 7.4 into 1 centimeter equals to 20 Newton. So 7.4 into 20 Newton equals to 148 kilo Newton. So you will get the value of resultant as 148 kilo Newton. And after using your protector at this point, you will get the value of theta as 64 degree. Simple calculation. In all these sums, you have to just draw the space diagram by giving the Bose notation, and then you have to select a suitable point, and you have to plot all the forces in order to achieve your closing line, and your closing side or closing line will give you your resultant by by using your scale, and then you will get the value of theta by using your protector. So these are the four examples which are related to Polygon law of forces. In all the forces, you have to just simply first draw the space diagram and then vector diagram. So in next lecture, we will study about free body diagram, and we will also learn the examples related to free body diagram. Thank you.